share my screen, and then we get going. I want to Okay, so I think we are here in this chapter, which is container runtimes. Um, so we did a small discussion last time, right? I think at least partially we were doing it, and then discussing about a bit on um, the C group and namespaces. Is that correct, Abdul?
Yes, so we had just started the third chapter, and we were just talking about container runtime interfaces. We did some discussion around Runc and Rocket, stuff like that. That's where we ended. But yeah, we can start with, I guess, C groups maybe again. We didn't really talk about it much.
Yeah, sure. So I'll just get my notes there. So I believe all of you would have heard about the C group, right? Uh, okay, so that's a note you have to put right now. Carlos, every time that the CNCF COC, right? You have to add it every time in the chat. Is it so? Okay. So I believe all of you would have heard about the C group or and namespaces. So C group is a way to impose the limit on the amounts of resources a process can use, right? So these are the concepts which are independent of the Docker or container. I mean that what I'm trying to convey is the features of containerization is part of the underlying OS itself, right? It is not something which is just Docker has come and made it happen. They have been there for some time, and then Docker just use them effectively to show us the power of containers and how we can do it in a much more easier and effective way. So there are two features of the Linux kernel which primarily help us do the containerization. One is the C group, which help us set the limit on the amount of resources, like how much a CPU and memory a process can get. And then we have the namespaces, which basically help us control what a process can see. What do we mean by that is um, when we um, when we create a process, we can configure a process can have its own view of the given thing. So, for example, the we can set host name for every program what we are creating. We can set the mount namespace there. So, how many have heard about whom they call as chroot? CHROOT. Anybody has heard about chroot?
Can you come again?
CHROOT. Chroot. Change root. We call it. Anyone? Or anybody has seen the kernel crash? Linux kernel crash? No, not really. Okay, I think I'm the oldest one here in that case. Yeah. Okay. So yeah, so Carlos saying that I use a metaphor C groups. You can control how much food and water it can eat, and namespace controls where it can go and play. Okay, nice. Okay, so chroot is a thing which, if you have seen the kernel crashes. So, for example, if the Linux or chroot is a general concept of change root. So we can change the root of a given program. So, so think about you are running a program, you are starting a system, whatever Linux you are running right now, and now you start another program. And for that program, you can say my root start from /mnt, for example. So for that new program, the /mnt becomes the new program where it's understand that's my root starts from there, correct? Um, so that is what chroot is. And then why I give the analogy of the kernel failure, right? So think about your kernel has crashed, and now every time you boot a system, right, it's always going to be in the same state because kernel went wrong, right? So what happens in that case is we boot from a CD-ROM or a USB drive, and as system boots up, it's going to get into the OS of that particular CD or the USB thing, right? And then once we are booted, so let's think about the kernel is loaded from the RAM, from the CD to RAM, and RAM you boot it from that particular perspective. And then we use this chroot command to change the root of the given kernel what you booted with to the root of the hard disk which has failed, or from where the kernel cannot boot. So what happened in the previous case, my kernel got panicked, but my remaining file system is perfectly fine, correct? So I can boot it from my USB drive or the CD drive. Then I change the root to a new location so that I can access my entire file system, what I have there. And then I can fix my kernel and come back to it. That is what chroot is. So chroot is a program which can just change the root of a given program for you. And this you can take back to 40 years back. And this is, you can think of the container history in a way, because you are just doing the namespace change of the mount. So what you see here, right? It's saying in the thing, right? We are able to do mount processes, names, network interface, and so on. So chroot can only do the mount. So chroot is only for that purpose. But if you add all of these things, you can get the containerization thing. Correct. So that is what something you can play with. Correct. So yeah, so that is something which you should be kind of looking into it further. So kernel C groups and the namespace are the features of the containerization, right? Then what happens next is, of course, I'll kind of go back to my next thing which I have highlighted there. So once basically, as you know, that Docker came, and then Docker basically um, took over the entire world by its own charisma and so on, 2014, 2015 time frame, right? And then it is kind of getting some kind of monopoly there, right? That okay, this is how you should do containerization, correct? And as I recall, I mean, don't take me other way around, other way there, right? So what I recall is when the Docker was trying to be, when Docker was at its peak, right, 2014 time frame, right? They were not kind of not so very open of the other suggestions from the other community members, correct? So and that's what kind of I recall and just have some of experience there. But then what happened is that's when then Core OS guys, right? If you heard about Rocket, right? They said that okay, now why one should do only Docker way, right? We should have other way of doing things, and that's when the Rocket got launched. Rocket is RKT, which is another runtime. So people are saying that why we need Rocket, why we need when we already have Docker, right? So it's kind of to make sure that we can have another alternative there. That's how we do it in the open source ecosystem, right? That we should have alternative and a way where all things are being defined in the right way. So that's when this OCI Open Container Initiative has come, and basically with this, what happened is the um, we came up with standard of how you should run containers, right? So think about if everybody comes. So again, if I kind of go back to the previous step, right? If you can create containers by just working with the C groups and the namespaces, correct? Um, then anybody can come and build a runtime, correct? Am I right? Because it's not the feature of Docker which is creating containers for you. It's a feature of Linux kernel, correct? So now, if the Linux kernel can create, if anybody can create these runtimes, right, or anybody can create the containers in n different ways, it's going to become problem, correct? And those people have that. Okay, why Rocket now, right? Because Rocket was, I think it was built primarily to kind of come up with a consensus saying that let's not just go one way, let's come and make a standard, correct? And that is when the OCI thing have came along, right? And then OCI thing came, and then we got this OCI standard, and out of this OCI standard, we got Runc as the basic um, implementation of that. So runc is the implementation, while OCI is the standard, correct? Now, of course, the OCI has three specifications right now. Uh, Basically, how you can run containers, and how you can have the images, and how you distribute them, correct? So this is now the OCI standard supports, or OCI initiative supports there. Any questions or any inputs you guys have here?
So runs is basically just a CLI, right? It's not a container runtime itself. Rather, it would handle the low level implementation details of the container runtime, like creating namespace and all those things.
You can divide the runtimes into two phases. One is a high level container runtime, and another is the another low level runtime. Correct. So while you can say runc is the low level, which is true, but it's a runtime because you can create containers from it, right? So it is definitely runtime which you can have. So yeah, so runc is a runtime, but you can say it's a low level runtime. Any other inputs, guys? Okay. So this is how the specification looks like. Let me open that here. Like this is how this particular file would look like. So a few things to note here is, I think I was looking for one thing which is not shown here, but what you see here, it's a specification. So basically, when you use the runc, you can give this particular specification to it. So OCI is a standard, and we kind of then uh, give that particular snippet, what we have here, right? Like what you see on the screen is a configuration file, and this configuration file can be given to the runc to create the container, right? So what you see here um, is a kind of configuration file. Now, one of the things we are looking here was rootfs. So rootfs, which is not shown here, it's a uh, location where your image is, correct? So to run a container, we need an image, correct? And that image need to be at somewhere. So when we define our rootfs, which means we are defining our image location, and then here we are specifying the command which you want to run, the sh command, right? So as you can see here, in which we are saying that you should use the shell command when the container starts. So we'll specify rootfs, and then we'll say specify which command to run. And then there is also a configuration which says that um, um, what are the namespaces you want to use. So if the time permits, I can kind of show you that in some time. But runc is going to look at this configuration file and the um, create the container for you. Um, Then what happened next is, of course, runc is a very low level runtime, so it cannot manage multiple containers by its own, because runc is like just to kind of create a container for a given purpose, right? So now then we kind of got into the next level or high level runtime. It's called containerd. So containerd can manage multiple runc containers, and that would eventually create containers for you, right? So containerd manage multiple runc containers for you, correct? And then Docker engine is on top of it. So Docker engine, containerd, and runc. This is how the Docker works. Are we good? Any other inputs, guys, here?
I see. Yeah.
Sorry.
No, I see. It's good.
Okay.
Like packaging abstraction over abstraction. So Rancy is one of the abstraction, and on top of that, container is another abstraction.
Correct. So containerd is a high level runtime, and then we have runc as a low level runtime there. Um, I'm just trying to see if I can show you that runc thing. Okay, possible. Okay, now this is the OCI image specification. Again, as you know that, right? All of these containers when we or container image when we build, right? They are they're kind of one on top of another, right? and that is what is being shown here. That let me just see if I have heard something. Yeah, yeah. So here it is the point.
They follow layered architecture.
Yeah, so it's like that
Yeah.
the image index on top level manifest that enables the creation of multiple. Okay, now this is different part. Sorry. Yeah, uh, so you have these layers, and these layers basically make up your images, right? So we have layer on top of another, and that is how the entire image would look like, right? So that is there. So I assume that you would have played with of a bit of images, right? So if you do a Docker image history to any image, right, you would see all of these layers, and then these layers would basically um, uh, would be of the given part. So how would I explain to you? Is it okay if I
So
share?
given each layer consists of a set of instruction or like uh, set of executables, and if you change any layer in so that what I understand from the layering is like if you have like five instruction in your Docker file, five line of instruction in your Docker file, like import base image,
Hmm.
import your code, import some library, run some update. Then each so there is a limit on the layering. Uh, wh- how much how much how much instruction, how much memory one layer can hold, and then the and layered are cached layers. And if you change any instruction at a particular layer, then all following layer will be updated after that.
I think yeah, you're almost there. I mean, what I understand that is there, but that is talking about the process of building the images, right? Here in the OCI specifications is that how these layers are put together on top of each other. That specification is mentioned here, right?
Okay.
So yeah, so I think that's good. And now I think we can also build these images on for the multiple. Just 1 minute. Yeah, so we can also now create multi-platform images also with this particular whatever the image building tools we are using, right? We can also build these images for the different architecture as well. Um, so while we are here, I just want to ask maybe a generic question if you have an answer for that. Like just to kind of a trivia there, not trivia, just to understand, get our understanding better there, right? So when you have these images, right, we have these image IDs and digest. So do you know what does the difference between image ID and digest, and why we need digest? Anyone has looked at what are image digest?
Um, as far as I know, those are basically the cryptographically encryption based on the content of the layers that it holds. So basically, if we have like we know that these Docker images have been stored as layers, and the content which it contains, some probably SHA-256 algorithms have been used upon to encrypt that content, and they specifically generate encryption key or something, or we can say a hash probably. So that
Yeah.
digest is the hash value that's been generated.
Yeah, so correct. So I mean, it's not encrypted per se. So I don't think it's encrypted that value. It is just check some of the data. So think about a kind of a use case there where let's say you as an image builder, right? Somebody who's building, who is writing the software, or who is build the image, right? You build an image and you push it to registry, correct? And now when somebody is pulling the image, let's say somebody hacks in between, right? And gives you a wrong image, correct? So when somebody gives you wrong image, how do you verify that whether the content which I have got is the same, the content is available on the registry or not, correct? That we do with the help of digest. So there's an image ID, there's digest. So ID is just a number there, like, but the digest is the content, right? What the hash value, because if you change a single bit also, the hash would change, correct? And then you can verify the content got changed, and then you would see something wrong has happened. I should either pull the image or figure out what's the problem there, right? And that is how I think the entire supply chain and all those kind of things built on top of it, right? That you kind of sign the image, then somebody can verify that and all those things. So I'm not going too much of detail of that, and I'm not the expert as there as well. But that is how the things are going to be built. That you should verify the content which you are getting, correct? And digest is one of the way of making sure that the content what you got from the registry or what you got pulled is the same on the registry. So that the digest, right? So you can look at, if you have the Docker installed, you can say a Docker image list or an image ls, and then hyphen digest. You can see digest is there, correct? And you want to add on that digest image IDs, something like that, or SBOM, something like that. Anybody want to add something on top of it? Okay, fine. Uh, 1 minute.
Just curious. So
Yeah.
whenever we create this digest or checksum, some
Mhm.
way, some unique way to identify the image, um, we can manually verify it from our end. But is it possible, or have you guys tried to verify this image within the pod or the container runtime itself? Some sort of automated process.
Come again from the. Can you
So,
come again?
like, we build an image and
Mm-hmm.
we push it to some registry,
Mm-hmm.
and we have some CD pipeline already set up, which would eventually pull that image and deploy it in the runtime
Mm-hmm.
in Kubernetes clusters. So, is there some automated process by which we can verify an image at the runtime itself rather than we manually doing it?
Yeah, of course. There are a lot of tools are available for that, right? So that is what I'm saying. The entire supply chain is built on that only, right? So that would help you verify those things. I think that's part we can discuss later. I'm not too expert on that,
Sure.
and but yeah. So there is no checking.
Yeah,
Uh, yeah, go ahead.
the that's a good question. Can you hear me?
Yeah, we can.
So, Kosh, so that's a good question. And then if you, I think you work on Kubernetes, but the digest the digest is something that identifies the image. So that goes into the when you ask for an image, when you're going to put an image, you put, instead of a tag, which everybody does, you want to put a digest. You never want to use a tag. And then there's no that thing that you were asking about, verification of automation of verification, is actually not needed, because the verification is yourself asking for the exact bytes that you want. So by putting the digest, that long string, in the image that you're going to pull, basically you're saying, I want the image that all the bytes, if you sum them together, a checksum, equals this. And then the container runtime, it will go to the registry and find the image that matches that digest that is burned. And if it finds it, it will give it back to you. If it doesn't find it, it doesn't match. So that's the verification. It's not explicit, but it's implicit. So that's why the automation comes in place when somebody creates a YAML file with the tag. Then you can have a CI/CD pipeline, Jenkins, or a mission control switch the tag for the digest. So Kubernetes never pulls the tag by tag; it always pulls by digest. And that's the automation process, not to the verification, but it's the swapping of the tag for the digest in a trusted way, that you're trusting that this tag means this digest. So that's why there's a effort in security of people not using digest tags. Tags is a human thing, but somebody can just switch the tag to another digest and another. They keep changing the tag, but the digest never changes. So Wanted to clarify that
Yeah.
there's no actual checking. That makes sense.
100%. Yeah.
Yeah,
Okay.
and just one point which I just remembered right now. So in Docker, if you know that there's some environment variable they have enable checksum. So if you enable the checksum, and if you do a Docker image pull, it would definitely go and check the do the local check and the remote check together for you. So if you in a Docker environment where you will set that enable checksum, something like that, then it's only going to get the image and verify that for you that the checksum is matching. It's not enabled by default. You'll do it or configure Docker daemon to do it accordingly there, right? So that is there. That I think the point was there. Okay. So let me reshare my screen and then we go to the next thing. Okay, cool. So then we come to the call as CRI, Container Runtime Interface. So as we all know that within Docker, earlier within Kubernetes, right? Earlier, only the Docker was supported as a container runtime. But then, of course, with the other runtime coming into the picture, we kind of uh, uh, supporting that CRI, which is Container Runtime Interface, to support different runtimes as we kind of um, have more runtimes in our bucket, right? So now there are many runtimes which are part of the Kubernetes ecosystem. One of them is Kata containers. If you have used them, and then there is other runtime which I think I talked about previously about this Kubelet, right? So you can create even VMs also. So though not a it's not a runtime to create, or it's not a container runtime or exactly to create a okay, so let me talk about that Kubert a bit, right? So Kubert work in two phases as far as I know. That Kubert, so when you create a VM with Kubernetes, right, using Kubert, it creates a pod, and that pod manages the VM for you. So, so essentially, when you managing the VM, you are working with the pod, and that pod eventually connects with the VM object in the ecosystem in the Kubernetes cluster there. So even those kind of runtimes are part of the CRI now. So CRI is the interface to support different runtimes. So we talked about Docker. Docker can be part of it. Containerd, CR-O, another runtime. Then Kata containers, and then you can also go with the for the Kubert as well. And you can build your own runtime. So there is a standard being given, and as long as you follow that standard creation, it should be perfectly fine. So the CRI interface is implemented using gRPC and protocol buffer. The interface defines two services, the runtime service and then image service. So as you have had understood from here, right? The runtime is to run the containers or the pods, what we're going to create. And then image service is going to basically help you get the image from the respective registries, whatever we would be having on our setup. Right. Okay, let me just go back, go forward. Yeah. So the container DCRI plugin starts with a gRPC server listening socket. That's perfectly fine. By default, so by default we have this socket. So if you are using the container D as a runtime, this is how it is. It is uh, going to be configured here. So depending on the runtime you're going to choose, right? Uh, the eventually that is what's going to be triggered, right? So even if you use, like in this case, it has been using containerd, so obviously containerd runtime, and that is what is going to be configured with the kubelet. um, just give me a minute, guys. Just make sure I'm on the right phase. So I'm not too much sure about this. Uh, Yeah, so I think that's as mentioned here, right? Once the pod is scheduled on a given node, the kubelet works. I think I need a diagram actually. Just wait a minute. I think yeah, this diagram I think would be helpful. So this is for Docker container D. Yeah. Okay. Yeah. So as you can see here, right, this CRI is kind of uh, playing a role here. So depending on um which particular uh, runtime you have configured. Based on that, the given flow is going to be picked up there. So I think okay, this is check. I'm just opening the diagram what you have given here. Yeah, okay. Let me just share my entire screen and then we can kind of open that up. Let me share the entire screen. Or you want to take that, Abdul? If you want to take that,
I think you can share. So I was just reading this and I found this diagram much more
yeah,
explanatory.
correct. Yeah, that's true. Because that
Yeah,
image was the book is a bit old, right? So that's what
yeah,
this yeah, this one, right? Yeah. So this is the diagram what you can see here, right? So Kubelet would use the CRI interface to connect with the given CRI plugin and image service runtime service I discussed. So it can be container D in this case what we have, and then it would go and connect to the container D daemon or something what you are running to kind of take the things further here. But what I recall, this particular image kind of moved even to the next level there, where the CRI by default implements container D. Oh, sorry, the CRI. Oh, sorry, yeah, this is fine. So I think as we understand from here, there is the image service runtime service, uh, and based on that we have the given whatever we have configured there, right? Container D, Docker, or CR-O or Kata container and so on. And based on that, our plugin would call to the respective service to manage or take it further to create the pods or VMs, whatever is the next step there. Um, okay.
yeah. So the life cycle of this pod thing is nicely explained if you go to the previous markdown page itself, right?
Hmm.
So I guess I mean a CRI typically would implement two gRPC services, right? The image service and the runtime service. So whenever the kubelet gets a command from the control plane that a pod needs to be scheduled on this particular node, uh, probably the first thing that the kubelet would do is it would call the runtime service and it will create something called as a pause container, right? So it's mentioned there. So the purpose of that pause container would be to uh, lay out and kind of configure the dependencies, especially around the network side of things, right? Because for a container to run, it will need some namespaces, it will need an IP address, it will need some storage, etc. Right? So this pause container would do all of that. Once that is done, what the kubelet will do is it will call the image service of CRI, right? The image service then goes and pulls the image of the container that you want to run. And after the image is pulled successfully, the checksum is verified and everything is done. There's a third call that Kubelet makes to the runtime service. And in this call, the actual container starts inside your pod, right? So I guess this is what I understood from this in a gist that it's a three-step process. First is it creates a pause container uh, by calling the runtime service. Then the image service is invoked, and then again the runtime service is invoked to actually run the container that you want to basically run inside the pod.
Right. So that is correct. So POS container is to set up the namespace primarily as Abdul was mentioning. And once the networking is being set or the namespace is being set, we can assign the network to it by the CNIs, right? So we need a namespace first to allocate or to use the CNI plugin to give its IP address and so on. So that is what the POS container would do for us. Let me just go back and reshare the other one. Okay. Fine. So So that is how the things are going to look like. That once you choose a given runtime, the kubelet would call the respective um, runtime what is being configured, and then that would take it further, right? So that is what is happening even in this case also. So in this case, we are going to go to this cryosoc. In the other case, we saw that we'll go to the container d.soc, and that is how the things happens. So uh, our Kubernetes users would not have to worry about what runtime is behind the scene. They would just run the kubectl command or kubectl command, and based on that, you can uh, it doesn't matter what runtime you are running behind the scene. Commands would always remain the same for the end user. So if a developer is doing it, the developer may not care about what runtime I'm using because those VMs or the container would always run as usual there. Correct. Um,
I guess in this case, the user would not be the end user per se, but Kubelet itself is the user, right? So now with the CRI thing in place, even the Kubelet does not care what runtime you have, as long as you have a
yeah,
runtime interface
correct. As long as you're
available.
pluggable there, so basically you just call the runtime that, but it has to be registered, right? One runtime has
Right.
to be registered, otherwise it
So
will not work at all,
yes,
right?
yes,
So
yes.
once
I
they are
think it
registered,
was mentioned somewhere in this that a kubelet config was also there, either here or somewhere else.
yeah, it's
So
there.
when you run the kubelet, you basically give the path of your runtime that
That is what is
this is the
happening. So,
runtime interface that
yeah,
we need
that
to
is what
use.
we discussed here. Yeah, here it is
Yeah,
there, right? Like
yeah,
when
yeah,
you
yeah, yeah.
when you specify that.
Yes, yes,
This
yes,
was, I think,
yes.
the previous case, but when the CRI would have come, it would have
Hmm.
changed a bit. Yeah.
Mhm.
So, Carlos, you mentioned a point here. Kubelet does not get called from the API server by the API server. Maybe I just missed that point. What was that?
Just a minor thing. At least I found it useful when I understood the communication between the contract between Kube API server and Kubelet. So there's a misconception. At least some folks have a misconception that the Kube API server talks to the kubelet anytime there's a new pod or there's a new container, and that's not true. But it feels like that way, but it's actually not true. What happens is the kubelet every X amount of time goes and talks to the Kube API server. So if you're opening network connections and things like that, or
Mm,
firewalls between control plane and data plane, which in cloud is very important with security groups and VPC.
yeah.
Um, so the
Mhm.
Kube is the one that needs to connect to the Kube API server just to get to the etcd database to find the pods that have the field saying the node label, right? The node selector, the node name equals that kubelet. So he's
Right.
just looking for work. So
Correct.
that
Correct.
kubelet goes and look for work. There's a communication happening from Kube API server to the kubelet, but that's only when you're doing kubectl exec. So that's something that it gets proxy from the kube API server and it finds the kubelet to do an exec on subprocess on that container. And also the other one is logs. So you will do kubectl logs, the kube API server, then it will connect to the kubelet to find that container and stream the logs back. So this that understanding of like the contract and the interaction between kubelet and kube API, at least if you're working on Kubernetes administration, is also useful to know.
Yeah, that's true.
Just
That's
passing
true.
minor
That's
thing.
true. So I believe rather than kubelet going back to the HCD, right? I think what I recall, and correct me if I'm wrong, that there is some kind of queue is maintained in the API server, and that queue is kind of read by the kubelet agents. So what I recall from my understanding, maybe I may be wrong as I said, right?
A
That
queue, you mean?
a queue API server manages like a queue for every worker node what is there, and then worker node kind of come and read that queue and figure out if there's a pending instruction or like getting the new pod creation on that, something like that. So because kubelet cannot read the etcd for sure, right?
Yeah, yeah. So
API,
that's why I
API
said it
server,
goes through the kube API server, but there's no maintaining of the. You said queue?
no, API server only. So uh, so what you okay, so what you are saying is that kubelet would talk via the API server to the etcd to
Yeah,
find
that's
out.
like everyone in the world who use the
uh,
Go client to talk to the kube API server, but the intention is to get information out of SCD, right?
Correct. Yes, that's true. Okay,
Yeah,
so
and then they use the informer pattern and the Go client, like best practices on how you connect to the Cube API server. Like you write the same way you write your little program of having a informer pattern with the Go client, and you have the queue, and then you reconnect, and you have a cache, right, on your side, on getting that information.
yeah. So main point here is that the kubelet gets information from the via the API server rather than the other way around. API server telling to the kubelets, go and do these things. So
Yep.
though
If
it is,
not, it will not scale, right? Like
yeah,
imagine you have I work with clusters of 5,000 nodes, right?
wow,
3,000 nodes. Then you cannot expect the Kube API server like send work to everyone. Like it's a better pattern of a pull method of like
mhm.
the workers pull for work. Like they just have a queue, like you said, have a queue of like they get work.
Yeah, very interesting point. That's a very interesting point from this session for sure. Yeah. Okay, so let's go back here. Yeah, so that was there. So now once we have an interface, um the CI interface, we are using that. Now, this is how the Docker was there earlier, because Docker engine, right, was not compatible with the CRI thing, right? So when you with a standard, right, you have to follow that, right? So when uh, Docker or when Docker has to be implemented with the CRI, so there used to be a Docker shim, which basically convert the CRI request to the Docker engine via Docker API. So this Docker shim was required because um, because Docker could not understand the CRI interface or CRI commands in a way, right? And now when the support of Docker was removed, it basically uh, this particular Docker shim got deprecated in a way, right? That Docker or Kubernetes would not support non-CRI compatible runtimes, and that's what it meant there. Um, but as this book is kind of bit old, it kind of talks about in detail, but that's perfectly fine. So Kubelet would talk to the Docker engine via the Docker shim, and that is what is happening here. And if you kind of read through it, you can look at um, the different containers by the Docker commands. And has anybody used the CTR command by itself? Uh, CTR command is for the container D. Has anybody used the CTR command as it's known? So I kind of use it a couple of times just for the fact to realize that it also has a concept of namespace within the container D itself, right? So container D can have, so this namespace is not like a Kubernetes namespace. It's just like if you have different um, I would say runtime. So, for example, or kind of a say like what the term they are using here. Um, so it's like a partition there, right? So, for example, if you are running container D and the Docker in the same machine, I believe if you use the namespace Moby, you can access the you can access the containers from the Docker thing. And then what Carlos saying that if you are using the Kubernetes one, you can use the -n k8s.io. So when you want to work with, when you are on the Kubernetes machines, and if you install the CTR command, you would not see the containers created by Kubernetes or Kubelet on its own unless you specify the -n namespace there. So -n k8s.io. That's something which is very interesting about what I learned earlier about the CTR command. Okay, anyway, rest of the kind of chapter goes through the same part there. Kubelet, the respective runtime, and the given plugin, whatever you have, that is how it is going to work. So it talks about that flow here, the system D, container D, and you can see that how all the things are connected here. And it's about Kata containers. So that's yeah, that's really a pain, Carlos. I agree with that. That because one time I was like wondering where all the containers are. Kubernetes says they are running, but where are they? So then I dig deep and then figure out there is a namespace called k8s.io to look at the containers via the container D. So that's how you would do that. Yeah. Okay, so Kata containers are the containers which, as you know, that it creates a lightweight VM for every container, right? So there was something called as clear containers, and then something called runv, whatever. They got merged, and then we had this Kata containers, and the Kata containers are there to create a container inside a VM. So what Kata container is managing is a lightweight VM layer for every container. So the idea is that the VM is much more secure than a container layer. And if we use this lightweight VMs, we are going to get the performance at par if I'm just using containers there. So again, this has been used in very kind of secured environment where it's must to create VMs. Kata containers have been there. So what you do is basically you create a new runtime class if you're using the Kata container. So you need to install a new runtime class, and then when you create containers or pods, you need to mention that I'm going to use this um, particular um, runtime class to create the containers. Yeah, hope that makes sense. And any questions here? Okay, and then we have this concept of a virtual kubelet. So it is like using some third-party service and referring as a Kubernetes node. And it is as simple as that. So as you can see, there are different services provided by the Azure, for example, here, or AWS Fargate, which you can register into your Kubernetes cluster as a virtual kubelet. And then when you're deploying a workload, you can say this workload should go and get deployed on the given kubelet or that particular service only. Make sense, guys?
I'm not very sure about the use case of virtual kubelet. Why do we do it in first place? Why do we need?
Why you would do it first place? So, for example, if you have already configured some kind of like service, right? A service which is provided by a third party or which is specialized service. We can read through it a bit. Let me see if I highlighted something on my own there earlier. Not really. Uh, yeah, like for example, serverless framework, right? So, for example, for serverless, you have not configured serverless in your Kubernetes cluster, but you want to leverage the serverless framework from AWS or Azure, wherever it is, right? So you can just implement that particular thing. So because you think that okay, the serverless implementation of Azure is the best, for example, for you, right? So now you can just add it as a virtual kubelet and then run your workload on Azure and come back and get the data for you, whatever is required there. So there are very specialized use cases there, but I'm not seeing a lot of practical use cases. But this is what it is right now.
Just hypothetically speaking, if I run a Minikube cluster on my laptop, and if I use this
Hmm.
virtual CRI plugin, can I provision like
Yeah.
containers on, let's say, if I use Lambdas for my workloads, would it be
Hmm.
possible? So Minikube running on my laptop, for everything that I deploy, a
Hmm.
Lambda should be triggered. Is that what it does? Because I've used Fargate and I've also used the normal
Hmm.
EKS. I didn't really have to
Okay.
configure anything specially with in terms of virtual kubelet or whatever, right?
Yeah, you don't have to. It is only when you want to add it in your existing cluster,
Mm.
right?
Yes, I mean theoretically, do you think it should be possible, right? If I run Minikube.
Yeah. So I'm not sure what Lambda can be configured as the virtual kubelet, but if it support, it can.
Mm. Since it says
So
Azure
that's what
Container
they are saying.
Instances, ACI, I think it's in the probably I don't know. Maybe I'll do a POC or whatever. Okay.
So Azure Connect Service is regular, like ECS, right?
Mm-hmm.
It's like
Mm-hmm.
that.
Yeah, Fargate is more similar to Lambda Notion, right? You don't really care about the infra,
Okay.
and it's you just give the pod YAML, and based on whatever CPU
Hmm.
memory that you have requested, it's going to
That will
provision.
work in that
Yeah.
case. So that will work in that case, yes.
Mm.
So not about your lambda per se, but if I mean, you can give by the Fargate
Mm.
thing there. Yeah. So there would be some requirement would be there that how it is to be done.
Mm.
So that has to be kind of maintained by the given provider. And if it is done, then you can add it.
Yeah, I'm guessing some kind of IAM access would be needed to uh,
Of
provision
course,
this.
that is
Yeah.
required for sure. That is required for that. You can't skip in AWS thing or anywhere else.
Cool.
Yeah, that's a must. Okay, so good. We have finished this. Now I have. Anybody want to see the Runcy in action? I can show you that if that's okay for you guys,
Yeah, sure.
because we just have very limited time, like 5 minutes left. So I can show you that quick demo of that Chiru were talking about, and then yeah. So Tapan has shared something. So I'll just see if I can show you that particular part. Again, I'm just showing you from the kind of a say, because as I know that we do trainings and we teach this particular part in our trainings, and then how does Chirut and the things work. So just whatever you can just see that I'm going to share some of the course content. So don't take it that I'm doing marketing, but it's just that I want to show the demo. That's why I'm doing it here. I'll just reshare my screen and then I can show you that entire thing. So I'll just mm, yeah, okay. So now what you see here is there's an instance what I have, and we have I just installed Runc on this right now. It's not installed, sorry. Nothing is installed. It's like fresh machine. So I'll show you the first demo of the not the right one. Okay. Um, Let me go back and get the sorry. Okay. Okay. I'll just stick with the Runc for now, not too much. So apt install Runc I'll do here. Runc, as this particular package got installed now. So now, assuming that, I'll just change the background here. Okay, hope it is visible to you guys. So now here, what we have is we have this Runc as a tool itself. What I'll do is we'll create a folder here, let's say XYZ, whatever, or labs. In this labs folder, currently I don't have anything. I'm going to run a command called runc spec here. This runc spec command is going to create a config.json file, as you can see here. And if I open the config file here, this is the similar thing what we saw earlier, right? That OCI configuration here. And you can see here, it is telling us, I'll just search for the root folder here. You can see here root path, right? So this is the location where your image is there. So when you are using the Docker as a runtime, right, or Docker as a tool itself, right? So when you say Docker container run, it is going to create something similar config for you behind the scene, and it's going to mount whatever the image you have into the given folder, right? And then um, and then and then it's going to use that as the root of a given container here. So assuming that if I had the a folder called rootfs here, mkdir rootfs, and let's say if I just put up, I need to have some binaries to run. So as you can see here in the config file, there is something called arg, right, which says what command to run once my container starts, right? So this binary need to be in that folder. Of course, I don't have it right now, but assume that if I have, right? So it's going to start the container with that folder and run the shell command there. And if I come down further, you can see that there is a configuration of namespace also. So this is how I can configure namespaces as well, like which namespace I want to use for this container to create it. So when I create a container, these namespaces can picked up based on the um, configuration what we have done here. So runc has all the configuration. So what it needs is it needs a folder where your entire container images, which it can take and then start the container from it. That's how it would work. Hope that makes a bit of sense. And I talked about Charut, right? Let's take a quick example of that as well. So as you can see, currently, I'll just do one here, and on the /mnt folder, I'll create a new root here, a random folder. Under that folder, I'll create some files here. let's say F1, F2. Okay. Now what I'm doing here is I'm going to start with run a root command, and then I'm going to run the bash program here. So I'll just look at the help one. It's been a while I did that. Yeah, the root command. Yeah. So I'll just say this, and now I'll just show you once. If I run the bash command right now here, right? Regularly that my current directory of working is this one, correct? I come out of this, but now I'll say root, and I'll say my new working directory is /mnt, this one, and then for the bash program. So now I'm saying that start my bash program with this particular new root. So, okay, I'll just say bin bash. Something is wrong. What's wrong? Bash. Okay. This is not working. It should have worked actually. Okay, I'll just use the without thing. It's been a while since I tried this program. Okay, I think I'm giving the wrong. No, this is fine. Yes, should work. It's saying chroot option and then new root directory and the commands which you want to run, right? Yeah, so it should work. Should work. It should work. New root. Okay, I'm not sure why it's feeling like that. Okay, I'm not sure right now. Sorry, guys. I'll see if I can get the demo next time. But hopefully, this has been a bit helpful here. Okay, so let's just look at what's the next for us, right? So in the next session, what we'll be doing is I'll just share that window. Where is it? Yeah. So in the next particular course, we'll go with the storage, right? So let's target to finish this entire chapter. It's going to be an interesting one. I think it's a smaller thing. So let's target to read this chapter in the next one in the next session. Okay. And I think we all should kind of come prepared a bit, read the chapter. So I think we all can give our inputs there, right? So that it becomes more interactive rather than a couple of guys just kind of going back and forth. So that's how it's going to be interesting, and then more life would come to the discussions. Yeah. Okay. Hope to see you guys in the next session. So next chapter 4, chapter 5, we'll try to finish. Yeah.
Cool.
Okay. How was it, guys? Any feedback you have? Anything you want to share? Did it go well? Not so well?
Yeah, it was good, but there was this one thing that Carlos mentioned about using digests instead of tags. I was
Mhm.
just trying to Google that, but I don't think there's much reading material.
Yeah, not
So,
required per se, right? It's just explanatory very well, right? See, if you are digest is always unique for a whatever I suggest is always unique, correct? So if you have the unique digest availability for you, you will pull only that from the Docker hub. That's it. Nothing more than that.
yeah, I understand.
Got it
But
right?
yeah, I was just thinking from the implementation side of things, like how would you kind of set up your CI/CD using digest instead of tags, right? How would that affect,
Yeah. So
let's
again, I
say
mean,
the.
not much actually, right? So when you are going to push that image to a Docker hub, right?
Mhm.
Then you can get the digest also. Even while pushing the image, right? You get the
Mhm.
digest ID also there.
Yeah, that's true. But I mean, see, using tags has some benefits, right? You can roll
Yeah.
back, you can go and check which version is deployed. So is there kind of a tool chain which kind of sits on top of this and does a translation for you or something? I don't know. I was just trying to look up, is it a good security practice to use digest
Good.
instead of
Yeah,
tags?
it is good security practice for sure. But that is when we need the that all the supply chain stuff. If you are just going to use the tags there, right?
Mm. Cool.
Yeah, so that's what you were saying anyway.
I guess
Okay, I think we are good. Yeah.
extracting the digest won't be an issue once the image is built. But again, as you mentioned regarding the rollback thing, we need to check what. And
So
again,
again, what does rollback mean? Rollback simply means going to a different ID. That's it, right? What does it rollback means? I mean, even if you do it like you just have a different git commit ID per se, right? Right. Now that is how typically people do a rollback. So basically, in our case, we use the git commit ID as a tag, right? That's a unique thing. So again, same thing. Digest is unique, right? So you know what digest you used previously. So why not? Correct. So I don't think anything changes in that scenario.
but the point is, tags are more human readable.
Yeah.
Can see the
Yeah, I
updates.
mean, if there's a production issue, I can say, I can call the developer and say, that version 2.3.3 is failing. I can't say
Hmm.
that ABCD 1952364 is failing. That's what I'm thinking in my head right now.
Yeah. Yeah.
So,
Okay.
yeah.
Maybe I don't have an
Cool.
answer for that. Let's
Cool.
just try to
I'll
figure
see.
out an answer.
Yep.
Okay.
Yep. Cool,
Let's come
man.
back with the
Sure.
next chapter 4 and 5 chapters. Yeah. Okay. See you guys.
Sure. Sure.
Bye bye.
Bye. Bye.
Thank you, people. Bye.